Okay everyone, today we talk about equally division algorithm. So that any positive integer in the form of 6q plus 1 and 6q plus 3 and 6q plus 5 where q is a some integer. Yesterday we talked about a division algorithm, right? I told you clearly what is division algorithm, how to define and everything we discussed. By observing here, using division algorithm, so that any positive odd integer in the form of 6q plus 1, 6q plus 3 and 6q plus 5. First I start with the division algorithm. Suppose a is my any positive integer. If a divided with some 6, because see here 6q plus 1 and 6q plus 3 and 6q plus. We know that any positive integer is divided by any other positive integer. It leaves some remainder and it gives some coefficient q. By division algorithm, dividend is equal to divisor into coefficient plus remainder. This is given by Euclid, right? Euclid. Division algorithm, right? That is given by a is equals to bq plus r and 0 always less than, remainder is always less than my divisor b. By this Euclid division algorithm, a is equals to 6q plus r, and I know that the remainders. If any integer is divisible by 6, it leaves the remainder 0, 1, 2, 3, 4 and 5, right? So can I write down all possible remainders? 0, 1, 2, 3, 4 and 5. According to these reminders, I will write the positive integer. A is equal to 6q plus 0, the first remainder. It may be my positive integer in the form of like this. Or A is equal to 6q plus 1. Maybe it leaves some remainder if any integer is divided by 6. Or A is equal to 6q plus 2. A is equal to 6q plus 3. And A is equal to 6q plus 4 and A is equal to 6q plus 5. So these are my possible positive integer if it is divisible by 6, right? Now we are going to discuss about so that any positive odd integer in the form of 6q plus 1, 6q plus 3 and 6q plus 5. By observing this one and this one and this one are odd positive integers. Why? Because I will explain only one of my 3 odd positive integers. A is equals to 6q plus 2 plus 1. I would like to write like this. Here and here 2 is common. From these two I will get 3q plus 1 plus 1. See here. This is in the form of some 2k plus 1. This is say some k, 2k plus 1. If any odd integer is divisible by 2, it leaves the remainder 1. It have 1 is a remainder if it is divisible by 2. Similarly, this is also we can write like this. This is also we can write like this. If you take this one. A is equal to 2 times 3 cube plus 1. Can I write like this or not? 2 3s are 6 cube plus 1. It is also divisible by 2 and leaves the remainder. Therefore, it is an odd integer or not? Similarly, can you try this one? We will get a remainder 1. It is divisible by 2. I will write it down here. 6 cube plus 4 plus 1. 4 plus 1, 5. Here we can write 2 times 3 cube plus 2 plus 1. Again I got 1 is a remainder from that 6 cube plus 1. 6 cube plus 5. Here also we will get a remainder, right? Am I right or wrong? Okay. So from all possible positive integers, I have 3 odd positive integers. Those are 6 cube plus 3, 6 cube plus 1 and 6 cube plus 5. You write it down at last. 6 cube plus 1 and 6 cube plus 3 and 6 cube plus 5 are the odd positive integers among all 6 positive integers. Okay?